and it's working. Yesterday, it turned off every time I started it. But it's working. Okay, that's so exciting. Okay, so up until this point, or at least the last few days, we've been talking about systems of equations. Y equals something. 2x plus 3y equals something, right? And we learned all these different ways of solving them. Now we're going to talk about systems of not equations, but systems of inequalities. In other words, they don't equal, or they might equal, but they also are greater than or less than, right? So you can have, with inequalities, you can have a greater than sign. You can have a less than sign. You can have a greater than or equal to sign, right? You have a little line underneath the greater than sign, or you can have a less than or equal to sign. Less than or equal to sign, yeah. And so those are the kinds of things we're going to be dealing with. We're only going to be focusing on graphing right now, okay? In fact, that's the only method that we will be using for solving systems of inequalities. Think about the difference, though, between equations and inequalities. An equation, if I drew a line here, or a graph, and I said, this is my line, okay? So figure that, just assume that's a straight line. Okay, and if I said plot that line, I mean, I would write down the line and I say plot it. It's only points on that line. Any place on that line is a point, right? Is a solution to that, right? Meaning, if this is 1 and this is 2, if this is 2 comma 0, right? 2 comma 0, that is a solution to the equation, right? And let's say this was, let's see, 1, 2, 3. Let's just say that. So we get down to, okay, so we have this equation is y is equal to negative 3 halves x, am I right? Negative 3 halves, that's right. Negative 3 halves x plus 3. Okay? Whoops, I've got my x. Negative 3 halves x plus 3. So with that equation, I forgot where I was going with this.
You're just talking about the difference.
Any point, like this is a point on the line, right? If I plug this into this, it should equal, I should get an equal, something that equals itself, right? So let's try it. 0, if I did this right, yeah. So 0 is my y. So 0 equals negative 3 halves times what? Times x, which is 2, right? Plus 3. So the 2's cross out. You guys all know that? I don't have to explain that at all. You guys get that, right? 2's cross out. So what I really have is 0 is equal to negative 3 plus 3. Is that true? 0 is equal to 0. Yes. That will always be the case when I do any point on this line, right? Now, if I change this equation, though, to not say equals, but to say less than or equals, then the only thing that would change is it does still equal this line, so it's still a solid line. You with me? It's still a solid line, just like I drew it before, because it's less than, but it's also equal to. So I can plot it just like I plot y equals negative 3 halves x plus 3. But it's also less than. So I have to figure out, well, which side do I shade? Because with an inequality, everything on one of the sides of the line is a solution. Everything. Like there's an infinite number of solutions. Infinite, right? So it's either all of this on this side that's going to be shaded, or all of this on this side. Now we got to figure out which side to shade, right? When it's in slope-intercept form, when it says y, it starts with y and it goes less than or greater than, then you can actually follow exactly what it says. What is less than the line? Here's the line, less than is all of this, right? It's like gravity tells you what less than is, right? You just put it up here and you drop it. Oh, this is the side I shade, right? That's what you know. But that's only true when it's in this form. If I give it to you in standard form, you can't use that method, right? So I'm not going to use that method now. I'm going to use the standard form method so you know it, right? The standard form method is you choose a point, any point on this graph. You could choose this point right here. You could choose this point right here. You could choose this point and this point. And then we're going to plug it in, just like I plugged that point in, right? We're going to plug it in, and we're going to see if we get a true statement. If we get a true statement, then wherever that point is, whatever side of the line that point is, that's the side you shade. If you get a false statement, 10 is equal to negative 17, not true. Therefore, you don't shade that side of the line. You go to the other side of the line and just shade that side of the line. Does that make sense? Do you get that? It's just, for most of you, the second, you've heard this before, so I'm kind of going fast, but some of you may or may not have, I don't know. So the only thing is, I don't want to really choose this point out here. I could, but I don't really want to enter 49.3 comma negative 72. I don't really want to do that. I want to choose a simple point. What is the simplest point on the graph?
0.
0, 0. Wouldn't you agree with me that this is the simplest point? Because then x is 0 and y is 0. Do you agree with me? So let's plug that in. That means if that's 0, 0, so y is 0, and I'm just going to write this. What is 3 halves times 0? Negative 3 halves times 0. 0. Anything times 0 is 0. So suddenly that whole term right there becomes a 0 plus 3. Now, is 0 less than or equal to 3? Is 0 less than 3?
Oh, no.
Yeah.
Is 0 less than 3?
Wow.
Yes, it is, right? And so I know that is a solution. 0, 0 is a solution because I got a true statement. That is true, right? That means I have to shade on this side of the line. Everything on this side of the line is true. I could try this one, and I could try this point, this point, this point, this point, this point, this point. All of these points, even way over here, even off the screen, even, never mind. So everything is a solution, right? And so I shade it like this. I don't shade it like this. I don't shade it parallel to the line, right? I shade it sort of like 90 degrees from the line, and I never want to shade it parallel to this line either, or parallel to this line. I just want it to sort of be clear. So that is my answer, right? Fist to 5. You guys get this? Make sense? All right. Now the second thing, though, is let's say up here, see how I said less than or equal to? Because it's less than or equal to, this is a solid line. But what if I erase this? So Gillian, look at this. What if I erase this? And suddenly I don't have the equal sign part to it. And I just had y is less than. What would I have to do to this line? Make it dashed.
Right.
Because the line becomes merely a boundary line. So I have to dash it. Does that make sense?
Could you do another one of these?
Yes, I will. Okay?
But that's
I have to do the dash because it does not equal the line. It's only less than the line. Therefore, it doesn't equal the line. So if it equals the line, it's solid. But if it's just less than the line, it has to be dashed. Because the dashed line says it goes up to that line, but it doesn't include that line. Does that make sense? Right? So that's what that means. Okay, so let's I'm running out of time, so what I'm going to do is I'm going to do another one on the same graph, okay? I'm going to write another one. I'm going to use a red. And this one is going to be y, let me think, y is greater than, yeah, that's fine. Y is greater than 2x minus 4, okay? Y is greater than 2x minus 4. So I'm going to immediately go down here and I'm going to plot this. 1, 2, 3, 4. I'm going to put my dot at negative 4, right? Remember this? You guys all remember this? Yeah. Dot at negative 4. And I rise 2 and run 1, right? So I rise 2, boom, boom, run 1, put a dot. Rise 2, 1, 1, put a dot. Ooh, look at that. That's where they hit. But I don't really care so much where they hit. 1, 2, 2 over 1. Boom. All right, so there's the dot again. So we've got all these dots. We're going to draw, what kind of a line am I going to draw? A solid or a dash?
Dash.
Gillian, is he right?
Dashed, yeah.
Dashed, for sure, yes. So it's going to be dashed Whoops, and it's straight as an arrow. Yes, sir. Okay, now I have to figure out how to shade it, right? Now, which side will I shade? Do we know? So what am I going to try? I'm going to try a point, right? My point is this point right here, 0, 0. I'm going to try that. So 0 is my y, is greater than 2 times 0 is just 0, right? Minus 4. So 0 is greater than negative 4. Is that true or false?
True.
That is true. That is true. Therefore, I got to everything on the side of the 0, 0 side is true, right? So I have to shade that. Now, when I shade this, I don't want to shade it so that they're parallel to this shading. Does that make sense? I want it to be crisscross because that's where you see the crisscross is the solution to the system of inequality. So here's my red line. That's what I'm doing. So let's see. I'm going to shade this way. Does that make sense? I kind of don't want it to be parallel to that line. So I'm going to shade a little bit off from that. I'm going to go like this. Boom. Boom. Because I'm including the 0, because 0 is true. This point, 0, 0 is true. So I've got to shade that direction. So I'm shading this way. Right? You guys with me?
Mm-hmm.
And so where is my solution? My solution is where the crisscross is. Is this a solution?
Nope.
No, because it doesn't have it's not on this side of this line, right? So it's right here. It's this part. It's this part, this to this. Do you see how those two, this section right here, I have double cross hatching, right? You see what I'm doing? See what I'm saying?
Oh, I do.
And so that is the solution. So when I graph these, usually I don't put these lines up here. I will do like this. I will wait until I've actually graphed it. I will go like this. I'll just put a little bit like this so I'll know, oh, it's that side of the line. See what I mean? And on this one, I'll do this side of the line down here, just a little bit so I know. And then instead of drawing, once I draw my two lines, then I say, oh, well, it's going to be this side of the line and this side of the line. It's going to be this triangle.
I did it on a separate graph. Same.
Oh, you did? Okay.
How
All
do
right.
you
Okay.
say the solution?
So I did it as a system of inequalities. Does that make sense, though?
Wait, how do you say the solution? Do you just leave it like
So
that?
the solution, yeah, you basically leave it like that.
Okay, no, I wasn't sure if like
You
said
don't, yeah,
that's
great
like
question.
graph.
It's a great question. You don't usually say a solution unless they might ask, and in fact on the homework I asked, give me 5 points that are solutions to this equation. So any
And then it's
5
somewhere
points.
in the solution.
Yeah, so we know 0, 0, right? Because we already figured that one out. That's definitely a solution. Look at that, right? Because both of them go through 0, 0. What about this one? This is -6, 0. -6, 0 is definitely a solution. Oh, -7, 0 is a solution. Oh, -8, 0 is a solution. Those are easy. Let's make it a little harder. Let's do -10, -1. I know that's one too, right?
So like all the
Those are all solutions. You see what I mean?
all those in those like two.
Yeah.
two
Any
shaded
point that's in this section here, and it goes on forever and ever, right?
Mhm.
Any point of there is a solution. Does that make sense?
Yeah.
So the homework is not very hard.
areas.
It's just graphing. First of all, just graphing one inequality on graphs, and then please tell me I brought them. I did, right? Tell me I brought them. I did. Phew. Okay, and I could turn this off.